Okay, welcome back to Mr. Hassan's Maths channel. I am going to be answering now a question that some of my students have requested me to answer from my end of topic worksheet number 9, which is integration from B1, and it's also from the Solomon E collection. The Solomon papers collection is in the paper E, and from that paper it's question number 10. Alright, so now, here we're told that there's a curve C with the equation y equals f of x, and it's such that dy dx, when you differentiate the function, you get the gradient function, is equal to 3x squared plus 4x plus k, where k is a constant. Given that C passes through these 2 points, 0, minus 2 and 2, 18, show that k equals 2 and find an equation for C. So the first thing we need to do, if we want to find the equation for C, we want to find y as some function of x. That would be the equation for C. So we got to find what y is. We have the gradient function, right? To find the original function, we have to integrate the gradient function. So when y is going to be given by the integral of the gradient function, which is 3x squared plus 4x plus k with respect to x. Now k is a constant, right? Like a number. So now, when we integrate this, we add 1 to the power, divide by the new power. So 3x cubed over 3. Add 1 to the power, remember there's a power here of 1 which is not written, gives you to the power of 2, divided by 2. Now the k is just a number, alright? Just like, for example, it's a number 3 or 4 or 5. When you integrate a constant, it gains an x. So this becomes kx, alright? And then you have to put plus c at the end to show that there is a constant of integration at the end, which is plus c. Alright, so if we simplify this first, we get y equals x cubed plus 2x squared plus kx plus c. Now, we know it passes through these 2 points. Those 2 points are going to help us find what k and c are. So let's take the first point, 0, minus 2. Most of you should realize that this is actually the y-intercept. When x equals 0, it's where it crosses the y-axis. So that's actually going to be your value of c. C is going to be negative 2. But if you want to just, be sure, you can put minus 2 equals 0 cubed plus 2 times 0 squared plus k times 0 plus c. And you see all of these become 0. You're left with c equals minus 2. So far in the equation we have y equals x cubed plus 2x squared plus kx and minus 2. Now we're left to find what k is. So we can use the other point that they gave us, which is 218. If we use that point, 218, then that will help us to find what the value of k is in the equation. So we replace the y with 18 and we replace the x with 2. So it's 18 equals 2 cubed plus 2 times 2 squared plus k times 2 minus 2. So that's 18 equals 8 plus 2 times 4, which is also 8, plus 2k minus 2. So that's 16 minus 2, which is 14. So 18 is equal to 14 plus 2k. Subtract 14 from both sides. So you have 4 equals 2k. Therefore k is equal to 2, which we had to show. But I think they also said write down the equation for C. So find an equation for C. So we found what k is. So now we can write down the equation with the value of k in there as well. So y equals x cubed plus 2x squared plus kx, 2x, we found it's 2 now, and minus 2. Okay, so there is the answer to part. Okay, there's the answer to part A, and I'm going to go to part B now. Now for part B, it says show that the line with the equation y equals x minus 2 is a tangent to C and find the coordinates of the point of contact. Now, if I want to find where a line and a curve or 2 curves intersect, I have to solve the equations of those simultaneously, right? So what I can do here is I can take this y over here and replace it with what y is equal to in the other equation. and then I would have an equation which I could solve them simultaneously. This is one method of solving this problem. Okay, so you have x cubed plus 2x squared plus 2x minus 2 is equal to x minus 2. So I'm solving these two equations simultaneously, right? So now, when I try to solve this, one of the things we'll realize that happens, which is going to be very useful for us, is the minus 2 and the minus 2 will cancel out if I try to bring them together onto one side. So I've got x cubed plus 2x squared. Now we've got 2x minus x, which is 1x, and minus 2 plus 2, which is 0. Alright? We can solve this equation. Alright? Because it's a cubic, but we have, a factor of x, which is common in all the terms. So we can take out the x. We've got x squared plus 2x, okay, plus 1 equals 0. So we have x equals 0, and we have x squared plus 2x plus 1 equals 0. Alright, now this is going to give us x plus 1 and x plus 1. Okay, so you end up with x equals minus 1 twice. This is a repeated root. This is like x plus 1 squared. So x equals minus 1 is a repeated root. Whenever you have a repeated root, you have the situation where the curve and the line, they touch. You understand? That's when you have a repeated root. So x equals minus 1 is called a repeated root. Okay? So we can see that the coordinates of the point of contact, alright, first of all, so that proves, as you can see here, the line y equals x minus 2 intersects, okay, the curve y equals f of x, we called it, please, at 2 places, at 2 points. Okay? One is when x equals 0, and the other one when x equals minus 1, and this is a repeated root, meaning it's a tangent at that point. So therefore, when x equals negative 1, we have a tangent. Okay, the curve and the line, they touch at that point. And we learned about repeated roots, so we have a tangent. Okay, so that shows that it's a tangent at that point, and it says find the coordinates of that point of contact. So we know that that's the point where y equals x minus 2. So when x equals minus 1, y is equal to minus 1 minus 2, which is minus 3. So we can say that's the point minus 1 minus 3. That's one way of solving this question, which is perfectly good. It's a nice way, right? We can also solve it in another way we could differentiate the original function, and we can make that equal to the gradient of this tangent. The gradient of this tangent is 1, because it's y equals 1x minus 2. Right? So the gradient of the tangent and the gradient of the curve, they're the same when they meet. You understand? So we could show that they meet at, that we can show that the gradient of the tangent, or we can find the places where the gradient of the curve is equal to the same gradient as the gradient of the tangent, and show that one of those points is on the curve. Okay, so if I did that, I'll show you how to do it that way as well. Supposing we did that, I'll just use this space over here. If we found dy dx, okay, you're going to get 3x squared plus 4x plus 2. And we want to know where the gradient is the same as the gradient of this line, because when they have the same gradient, that's what a tangent is. It has the same gradient as a curve at the same point. So let's see where this gradient is equal to 1. So 3x squared plus 4x plus 2 equals 1. So you have 3x squared plus 4x plus 1 equals 0. So if we solve this equation, we can solve that equation by using our grid method, if we want. So we have 3x squared and we have plus 1. Two numbers multiplied to give you 3x squared, add to give you 4x. Well, it's again 3x and 1x. Right, so the common factor here is 3x. 3x times x is 3x squared. 3x times 1 is 3x, and x times 1 is x. So this gives you 3x plus 1 times x plus 1 equals 0. So there are two places, okay, where the curve has a gradient of 1. One is when x is minus 1/3, and the other one when x is equal to minus 1. Now, to find out, okay, which one of these points is the point where it's going to be a tangent, you can substitute this value back into the original equation and find out what the y value is at that point. Okay, if you put minus 1 into here, you have y equals minus 1 cubed, which is minus 1, plus 2 times minus 1 squared, which is 2, plus 2 times minus 2, which is minus 2, and then minus another 2. So y is going to be, that's going to be minus 4 minus 5 plus 2 minus 3. And you want to check if the point that we just found minus 1 minus 3, is it a point that's on this line? Well, yes it is. When you put x equals minus 1 in here, you get y equals minus 3. So this point is a point on the curve where the gradient is 1, and it's also a point on this line. So it shows that this point lies on the curve, okay, and it also lies on the line which has the same gradient of the curve at that point. Okay, so that's like a longer way of doing it, right? Yes, Mr. Yasin.
So this way is when you do it with the differentiation equation.
Sorry?
This is the way that we do it with the differentiation
Yes.
equation, not the integration. Right?
We don't integrate here, we're differentiating, yes.
I'm saying that the previous example we did it with the integration.
No, we didn't integrate this. We just made them equal to each other. We said the curve and we use simultaneous equations. We said the equation of the curve and the line, okay, we solved them simultaneously. We found the places where the curve and the line meet. They met at two places. One of those places was a repeated root, and the other one was a single root. The repeated root is where you'd have a tangent, because the curve would just touch, the line would just touch the curve at that point, right? So that's how we proved it in that first way. When we've got the repeated root, that is the place where the tangent is. The other way, we found the places on the curve where the gradient is the same as the tangent that they gave, the line that they gave, right? And if we can show that the point where the curve has that same gradient is the same point that lies on that line, then we know that that's a tangent. Yes?
Sure, so...
Mr. Mikhail.
Yes, featuring me. Sure, so it touches 2 points, right? On 2 points.
Look, it's like this. This is a cubic curve, right?
Yeah.
Okay? Something like this.
Yeah.
Say the gradient here is 1.
Yeah.
So I'll just draw a straight line. At that point, say that's the point x equals minus 1. There's another point somewhere over there where it also intersects.
Yes.
So at this point, it's a tangent. At that point, it cuts through.
So I have to label, because I found both coordinates.
When you did what?
When you did the first method,
Yes?
yeah, once I got the thing, I swapped it and I found the both coordinates.
You don't need to find both coordinates.
Yeah,
You
but
should.
I did.
Yeah, but the point is, it's where the repeated root is that you're going to find the tangent. They're not asking you where they intersect.
Yeah.
They're asking you, okay, to show what the tangent is. To show that.
Should I like underline it or something, or like say this is the tangent?
Yeah, you say this is repeated root.
Yeah.
Because it's repeated root, therefore we have a tangent at that point.
Okay.
Okay, and then you find the coordinates of the tangent. Okay, you don't need to find the coordinates of the other point. Okay, because it's not saying find the points that would say intersect, it's saying find the coordinates of the point of the tangent. Okay?
Okay.
Yes. Sorry? Okay, because I can do. Excuse me. I can do. Alright? If I had found that x equals minus 1, okay, didn't give me the same point as on the line y equals x minus 2. Okay, so if I put x equals minus 1/3 into this equation, found the y value, right? I have a coordinates of another point on the curve where you'll have minus 1/3 and something else. If that point is not on this line, okay, then that's not a tangent to the curve at that point, because there could be more places than one where, for example, this line also has a gradient of 1. Right? Do you understand? This line also has a gradient of 1. There's many places. What we found is the two places where the gradient on the curve is equal to. We found this point here. That's one of the points we found. Alright? Okay, but that's not the same line as this. Okay? The line that we wanted to prove is a tangent is this line. So that's the point we're looking for. Alright? The other one would represent this point, which is not the same line. So if I had found that the first one I tried did not give me the same y value as is on this line, then I would have gone to minus 1/3. Okay?
How do you know that?
How do I know what?
How do you know that minus 3 is the correct value? It could be something else for a while.
Because that's a point that exists on the curve and on the line.
You find that out later, right?
No, you don't. You substitute, okay, the x value that you found into this curve, and it gave you y equals minus 3. And the point x equals minus 1, y equals minus 3 is also on this line. They're both on it's on this line and it's on this curve. So that means that's this point over here.
No, my question is, for example, like what I did was I found 2 points, right? X minus 1 and x is equal to minus 1 over 3.
Okay, minus 1 over 3. If you substitute x equals minus 1 over 3 into the curve, it will give you a y value, right? Into this curve, it will give you a y value, right? And that point will not exist on this line. It's another line. That point exists over here. That point exists at this line. That's not the same as the line which passes through the point, okay, that is required. That point here is a point on the line where y equals x minus 1. Do you understand? Okay, this point, the other one you found is minus 1/3 and something. If you put those values into the original equation, okay, that's a point on the curve, right? But that point is not on this line.
But how would you know that? Like by putting it into the
Yes, you'd put it into this equation and you find it doesn't satisfy this equation.
Yeah.
So therefore, this point is not on the line. So it doesn't prove that this is the tangent of the curve.
Exactly.
Do you understand?
Yes.
Alright, so the second way, finding the places on the curve where the gradient is equal to 1, right, gives you two answers. One of those answers, find the y coordinate of that point, substitute back into the original equation, okay, and then you'll see that it's the same point on the line and the curve. This point, the other point you find, it will not give you a point that's on the line. It will give you a point that's not on the line. It won't satisfy the equation of the line. Therefore, although the gradient there is 1, okay, it's not where this line is a tangent to the curve. It's a different line. Okay? But the first way, I think, is shorter, where you basically solve the equation simultaneously and find that you have 2 points where the curve and the line intersect. One of them is a repeated root. That's what a tangent is, when you get a repeated root. It doesn't cut through, but it touches the curve. Alright? Is that clear, everybody? Okay. Alright, so that concludes this question. Question number 4 from the end of topic worksheet. Question number 10 from the Solomon E P1 papers. Other questions from the end of topic worksheet you'll find in the playlist that will appear somewhere in this area after the end of the video. Down here you'll find questions from the Solomon E P1 collection, and if you would like to subscribe to my channel, you can do so by clicking on this link in the middle of the screen. Thank you for watching and see you soon.